Yeah, it was a long day. We'll try to keep it pretty lighthearted, don't worry. So I'm Philip, and we'll talk about 101 steps to avoid a security disaster in the cloud. Obviously, I will need to speak pretty fast to go through the list of 101 points, but yeah, let's jump into it. I'm from Vienna, capital of schnitzels. We also have beautiful buildings and many beautiful women. Yeah, joking aside, I've recently joined Elastic. I'm on the infrastructure team. We do stuff like Amazon Web Services. We provide Ansible scripts, Docker containers, Jenkins. And when I'm not at home working for the infrastructure team, I'm out at conferences and meetups and sometimes companies to do some demos and show off stuff. So let's see, who is actually using Amazon, Azure, and stuff like that at the moment? So very few. That's very German. Super conservative. Everything is in my own data center, and if I'm not owning it, yeah, it's not good. Yeah. Okay. So in other regions, nearly everybody raises their hand when I ask like who is using the cloud. Yeah. Maybe it's secure. Maybe it's not secure. Let's take a look. So. General question is always like, does the cloud solve all your security problems? And well, answer is no, unfortunately it's not, but still, at least the Americans are a bit more open about the cloud thing. And they say, yeah, we probably are more secure on AWS than in our own data center, because Amazon has lots of experts who are just focused on their specific tasks, like security experts. They probably have 10 or more security experts just working on security than you have for your own data center and all the stuff you do. So yeah, they're a big target, and if bad stuff happens, it would make some waves. But so far, they seem to hold up pretty well, because I'm not aware of any major attacks just on AWS itself. I mean, of course, generally security bugs, but generally AWS is pretty secure. They have their security bulletins. Every now and then something comes up, but yeah, that mostly is about Xen, their virtualization, and stuff like Heartbleed. Of course, it's in there. They have the same problem as everybody else, but it's not less or more secure than your stuff or your own data center. So we'll not really focus about that, but we'll talk about the real problem. And unfortunately, the real problem is normally us. What do I mean by us? I'll just start off with 3 examples where you can see stuff going terribly wrong. First off, there was code spaces. Yes, there was. It was something a bit like, I think, GitHub, so you could host your software there. I think you had issues and stuff like that. The problem is somebody got access to their tokens and credentials. And yeah, they tried to blackmail code spaces and said like, yeah, hey, we have access to your stuff. And they started adding some funny notes on their infrastructure. And asked then, okay, so pay up and we'll go away and we'll leave your stuff alone. But Codespaces thought, well, we're cleverer, we'll just throw them out quickly, and so they started to try to cut off access. And then the attackers got kind of mad and terminated everything. And everything is really everything. Because what they really asked for, or what Codespaces advertised in the beginning, is like, we have backups for everything, and you don't need to worry about anything. The problem was they had the backups in their own AWS account with the same credentials. So the attackers just terminated the instances with the stuff plus the backups. And there was just no way to get it back. And this was the last message of them. They've shut down since, and yeah, some people lost code and issues and stuff, so not a good idea. Second example is DrawQuest. DrawQuest was some community-driven game. It had been going on for years and years. It had its loyal community. People were playing it, but it was just run by enthusiasts, so there were no professionals on the team. And yes, somebody managed to break into their system because somewhere there was a token somebody found and started to mine bitcoins, which totally doesn't make sense on AWS, because you need to spend like, I don't know, $1,000 to make $10 in bitcoins. But if it's not your own money you're spending, it's still a good win. So many people will want to do that, and yeah, for DrawQuest, this was also the end because they didn't have a dedicated team and they didn't have the resources to clean up and pay the bill, so they had just to shut down the entire thing. And yeah, doesn't look so good. And then there was Bonsai. Bonsai, so I'm not really intending to bash on them because Bonsai is providing hosted Elasticsearch. But they have been doing that for a long time, and they had also a very interesting incident. Someday they woke up in the morning, like the evening before everything was running fine, and then they woke up in the morning and their infrastructure was gone. Because someone, probably a competitor, nobody really knows, also found one of their tokens and just decided to terminate their infrastructure during the night. So they didn't even want money or ask for money in the first place. They just terminated everything they had on AWS. Yeah, somewhere there was an API key in one of their internal components. They pushed that to GitHub as a private repository and said, well, the key is in there, but we don't really need to care about it because it's just private. And then at some later point on, they decided, well, this is actually a useful thing. We will just open source it. And they put it in the open. Somewhere there was the key in. And yeah, someone found it, probably a competitor, nobody knows because they didn't ask for money. And yeah, just killed everything. Luckily, they had backups which either were not deleted or they couldn't delete with that key, I'm not sure. But it still took them 4 to 48 hours just to restore everything. And if you're a customer, you're probably pretty pissed off if your search is gone for 48 hours. Surprisingly, they're still around. They survived that attack, but it was not pretty. So I know what you're thinking. Probably you should start drinking when you're using the cloud. Yeah, so just to avoid that, we'll now talk about the 101 steps to secure your account. So let's jump into it. Starting at 0, accounts. First off, whenever you have, for example, especially if you're on Amazon, what you get in the beginning is a root account. Don't use it. Normally what most people do is they get the root account, they set everything up with the root account and use it, and after 2 years they come to the conclusion, well, this might not be the best idea. Why? Because there are absolutely no restrictions for the root account. If somebody gets access to that account, it's game over, you're gone. So take that account, take the password, lock it in your safe, remove it from all your password safes and everything, just keep it somewhere written down in a safe, but never actually use it. Instead, what you should use is always use the Identity and Access Management, IAM, which is the management AWS provides. So you can actually create another or different accounts, and you have lots of different restrictions on that. And it's one of the many services AWS provides, but this is actually pretty easy to remember because I always remember it like that. Yeah, that's kind of the point of I am. I am what I am because you define all of it in I am, and that's where you actually keep your stuff. And please just create one user for every account you have and also your services. So every internal and external service, if you have your own users, if one of them gets compromised, you just need to rotate that one. And you can actually know, okay, probably this was the compromised account. So it's very easy or easier to rotate that one and not just have a huge mess and needing to rotate like everything within your infrastructure. So you just, right from the start with clean separations of accounts. Also, if people leave your company, it's very nice just to revoke their credentials and not just have one shared credential, and then afterwards you just need to hope that, yeah, the separation was kind of nice and nobody is kind of pissed off. Secondly, access. Obviously, only allow what is necessary, principle of the least access. So what AWS provides for you, you have groups. You can always give permissions to specific users or the accounts a specific service is using. Don't do that. Group it nicely so you can actually reuse it. And what this will look like, something like this. So this is pretty blue. I hope you can still read it. So what I'm doing here is I'm allowing whatever user gets this permission or is within that group, you're allowed to do something. So you can list all my S3 buckets, so the file storage on AWS. You can list a specific bucket, and then you can store objects, read objects, and delete objects from COM example, backup, and everything in there. Even though this might not be the optimal rule for a backup, because for many backups you just do not want to delete stuff. So if you get compromised, just remove that last S3 delete object rule, and even if that account gets compromised, while it can put stuff there and read stuff, maybe you don't even need to be able to read stuff, maybe you just need to be able to put stuff there, and once that is compromised, it's not as bad, because nobody will be able to just remove your stuff and then you're stuck on an empty account. Yeah, you can group, or people can be in multiple groups, and I think you can even nest groups. So this is pretty powerful. In the beginning, it's a bit confusing because the JSON syntax is not that nice, but there is a policy generator from AWS, and you can check stuff, and you can simulate rules, so you can very nicely test and work with that. Okay, next up, authentication. Those who were watching out can see we're in binary notation. So yeah, it's not as bad. 101 won't take forever, don't worry. So authentication, obviously use strong passwords. I guess everybody knows the battery horse staple, just remembering strong passwords. Probably the better approach is still to use a password safe and generate random, very long passwords. Amazon allows very long passwords. I think, at least with my Amazon Office 365 account, I had some limits on my passwords. I think it was like 15 characters. And I'm always feeling like very weird. Why would you have something like that? I don't know. If you hash the password, it doesn't really matter how long it is. I mean, probably you want to limit it to 100 characters or so, because otherwise hashing can kind of become a denial of service if you just throw very long strings for the hashing. But up to that, it should be pretty fine. And the next thing beside a very strong password you should always have and enforce is multi-factor authentication. So you'd always have a password, and then you get one token, and only if you have that token that is valid for 1 minute, you can actually log in into stuff. So what this will look like is something like this. So you always need to provide an account, the user, the password, and then the multi-factor authentication code. And without the code, you cannot do anything. So this is more secure. The only problem is, what happens if you break your phone? So normally you have the token on your phone. You can go use the Google Authentication app. Even Amazon is using that. Only what happens if you break your phone and you lose your token? So as long as you're on an IAM account, everything is fine. But because you can either reset that with the root account, or you have another IAM account that can actually manage users and IAM accounts, then you can reset that. What happens if you lose access to your root account? Unfortunately, at my previous company, we've tried that out. It wasn't me. I know nobody's going to believe that now, but it wasn't me. It was like our CTO. He had it on his phone, and I don't know, something was wrong with his phone, and he just did a hard reset, and then the token for the root account was gone. And we were like, okay, we don't really need it, and we don't really want to use it, but probably at some point we should have that back. So it's not really urgent. We didn't need it on a daily basis. It was just something we, in theory, would like to have access to that at some point again. So we had paid support, and we had like 3 named contacts on AWS. With phone numbers, email addresses, and names, and they hadn't changed in like the previous 2 years. So we thought, well, this is probably easy. They will just call each of those 3 telephone numbers and send an email, and if all 3 people say, yeah, please, this is us, reset it, it will be easy. Unfortunately, it is not, because I don't know why, but AWS is pretty paranoid about that. So no, support said, no, we cannot do that. It's not working like that. So we went to our account manager, and our account manager said, yeah, let's see, we've been in touch, so yeah, you seem to be the same guy, so I'll try to get it back to you. And then he came back and said, like, no, you cannot get it like that. You need to go to a notary, and the notary needs to write the form and sign the form just to tell, okay, this is actually this company and the same people, so you get the access back. So they sent us an English form, which is no good, because we were an Austrian company, and an Austrian notary can only sign German stuff. So we then needed professional translation services just to translate the form. Then the notary did his thing, and obviously took a lot of money for it. Then we went through an official translation service again, and then we got the access to our root account back. So don't do that. What you normally can do is, first off, use a hardware token. Since then, we've bought the hardware token. I think it's $20. YubiKeys don't work at the moment. There's just one brand that works. Amazon obviously sells it. So you can get it, but it's not that expensive. And it's a good investment. It's just like, we got the hardware token, we put it in some safe. Nobody is using it, but we have access to it. And secondly, there are always fallback questions, which are normally quite a big security risk. So with our original root account, we thought, well, we're super clever. We won't get hacked by that. We'll just add random strings into the 3 questions. So we did, but we didn't write the random strings down. So that was kind of blocked. And now that we had access back to the root account, we did it differently. Like, again, we generated random strings, but we then split up the strings. So we were 3 people on the team who were doing most of the AWS stuff, and each one of us just got 1 string. So you need all 3 of us to put it back together. And since I've left the company, I still think I own one of these. It was just like, while preparing the talk, I kind of remembered, I still think I'm the only one who has that key. So I'll reach out to the other guys and see if they missed a key or if I should just delete it, or yeah. I still have it at the moment, so let's see. Okay, so yeah. Next up, code. This is probably pretty obvious, but never commit your credentials. What is super common is that people have something on a private repository and think, yeah, I know it's dirty, but I'll just put it in here. It's really quick. I don't really care. We'll just push it. It's a private repository. And at some later point on, somebody open sources it by accident, or like just forgot about the key and open sources it. And then somebody will probably find it, because the bad guys are unfortunately not stupid. They constantly scan GitHub for AWS tokens. You can just write a regular expression and scan all the code that is being pushed for that. And at the moment, it's kind of an arms race, because it's so common. AWS does the same. And so whoever finds the key first either starting Bitcoin mining instances for you, or they simply kill the key for you. So it's kind of like good or bad luck. I've heard that the bad guys are still pretty quick, because every now and then somebody complains about the $5,000 bill because somebody started mining Bitcoins. So just don't commit your credentials, because it's expensive, it's embarrassing, and if the wrong people get your tokens, it is also very, it can just destroy your company. Next up, networks. Enable IP restrictions. This is obviously for instances, kind of obvious, but you can do the same for users and IAM accounts. So what we did in this example is, for all the actions my user was allowed to do, so I simply had an allow all rule, allow every action on every resource, but in addition to that, I added a deny rule, and there I say, disallow everything unless coming from one of these 2 IP addresses. And you can simply add your Office IP address and your VPN IP address. And even if you give out your keys and even the 2-factor authentication code to somebody else, if they come from the wrong IP address, they cannot do anything. And this totally makes sense, because why should some account from Russia or China be able to access our AWS account? Just no point in that. So as long as you have a static Office IP address and a static VPN address, just limit all interaction from your tokens to that. And you can always only connect to your, from your Office or through your VPN. And otherwise, no harm can be done. The only thing that is slightly confusing, even coming from the wrong IP address, you can still log in successfully. But if you look closely, you can actually see all the actions there you have is, says you are not authorized. Because what basically the web interface is just like a wrapper around the web service calls in the background, and all the web service calls are failing because you're not authorized. So yes, you can log in, but you cannot see or do anything. And this has been sometimes confusing for my colleagues, because they just logged in from the wrong IP address, and then suddenly nothing was working. This is security at work. Okay, next up, tools. What is very helpful is enable billing alerts. So you can just define thresholds and get emails once you've reached a certain threshold. Once again, the bad guys are not stupid. Once they get your keys, they will wait for the end of the month when you get your bill. And so they will start mining Bitcoins on the 1st or 2nd or 3rd of the month. So they have as much time as they want during that month to do bad stuff, and you will probably only see it on your credit card statements at the beginning of the next month. So if you have billing alerts, just kind of, so we defined rules, okay, we know kind of what are we spending during the whole month. So we set an alert for what is at the middle of the month approximately, what is at the end of the month, and then we had an alert which was like 20% or 30% higher. And if we ever got that alert, we knew, okay, something was off. Most of the time, you've just messed up and started some instances and forgot to terminate them or did some other bad configuration. But in the event, if somebody actually hacks you, you will notice pretty quickly. So read those emails. Next up is CloudTrail. CloudTrail is just logging all the actions your users are doing, which is super helpful if one of your, or if your account is compromised and you have like 50 keys out there, you have no idea which key has been compromised and which key is actually destroying stuff. Unless you have enabled CloudTrail, because CloudTrail just logs every interaction you have. For example, in this, here you can see that one instance was, what was it? I think it was stop. Yeah, stop instances. Yeah, the instance was stopped. It was running in EU West, and the user was actually Alice, and whatever key she had. Yeah, so okay, if you have terminated instances, just look at the trail, and then you see people or whichever account actually terminated your stuff, and then you can just disable the key, and it's pretty quick to do that. Otherwise, it's just lots of searching around. Which account is it? Just rotate all the keys, and it just adds lots of confusion and overhead. Like this, you can pretty easily find the key that is the problem. Next up, there is this nice thing called security status, which is just a basic checklist, and it doesn't always need to be green, but if not one of these points is not green, you should have a valid reason for that. So it just checks like, do you have multi-factor authentication enabled? Yeah, do you have different IAM accounts? Do you have a password policy? So we always enforce a password policy, I don't know, at least 10 characters and uppercase, lowercase numbers, special characters, whatever. So all of this is possible, you just need to configure it correctly, and then you should be relatively secure. What you can also do is, there is something, if you have premium support, called Trusted Advisor, and there is 1 point security. It's not all that clever, but it's still kind of helpful. For example, in the security area, you see, okay, 5 of our checks were green, those are good. 4 are yellow and 2 are red. Even though I think 2 of these reds are, you have opened a port to your instances globally, and that port was 443, which kind of is necessary. So the check is not all that helpful, but it just will list all of the stuff like globally open ports and all the configurations you can have. So you should at least check that, and it can also send you weekly emails if stuff changes. So if stuff changes from green to yellow or red, you will get an email alert and can see what has actually changed. Okay, so these are kind of the general guidelines. Now, how do you actually implement that? So first off, if a key is compromised, rotate it. Sounds obvious, but some people overthink like, well, this was only up for 5 minutes. Probably nobody has seen that. Yeah, we'll simply, if you have pushed it somewhere, you will simply remove it. If you're good with Git, you might even rebase and remove it from the history, and then you think everything is good. Unfortunately, again, the bad guys have kind of learned, so they could just monitor every push. So once it's pushed out, it's out. So simply forget about the key then, regenerate the key. Don't rely on, oh, I was so quick, nobody could have seen that. Just regenerate the key and have some kind of automation where this is not too difficult to actually do. The second thing is keep your secrets, which again sounds super obvious. How could you do that? First off, environment variables. Don't have your secrets committed anywhere in your source control management, just use environment variables, which is kind of nice. It's just the pain to get started, especially if you have set up locally and you need to tell all your colleagues what are the passwords. Everybody needs to have kind of the same environment variables, or just need to add some environment variables, and needs to do that. And if you have everything automated with Ansible, Chef, or Puppet, SaltStack, whatever, you still need to tell that which environment variables to set. So this is kind of a chicken egg problem. So what you could do instead is you could just push your stuff in an encrypted fashion to source control management. And the third options are vaults. We just had a talk, I think, today about vaults. So there are multiple options, but let's take a quick look. The source control thing, there is one nice blog post, keeping passwords in source control, how to actually do that, written by a guy who's running ejon.org. Does anybody have an idea who ejon is? Nobody knows him. Okay. Well, ejon, he did some JavaScript stuff. He wrote this library nobody knows. Yeah, it's John Riesig. That's his personal blog. And they had the same problem. So he changed after jQuery, he changed to the Khan Academy. And there they had this problem where they said, well, we want to have this super simple. So we want to have security, but we also don't want all our developers just setting up environment variables on their own machines, and then we need to distribute that out to our production servers, and this is just a pain. So how do we do it? And they wrote this super simple script. I've slightly adopted that, but it's just the shell script. So you can either, if you're on Linux or Mac, you're good to go. If you're on Windows, you will need Cygwin or some stuff like that. So you simply run that script against the file, and it will simply check the file extension. For example, I've added the file extension AS256. If that file is there, you assume the file is encrypted, so you need to decrypt it. If the extension is not there, so there's some other extension, you simply encrypt the file at the file extension. And I think I'm also removing the unencrypted file. Yeah. So you can do this. Why am I changing the file extension? The nice thing is you can just put the file whatever the file name without the file extension is, you can put that in your git ignore, so nobody can push that by accident. By changing the file extension, only the AES-256 encrypted. Yeah, my computer always tells me the time. We don't need that. If you have the file name, with the file extension, just put the unencrypted version in git ignore, so you cannot push that by accident. Yeah, and then you simply run the script, and you're good to go. So what this would look like, assume you have, I don't know, I have a Java trust store here. I simply run the encrypt, I call it encrypt decrypt script, run it against my trust store. It asks for a password. It will obviously ask like, yeah, ask the operations guy that was at my previous company still. If you're a small company, this will probably kind of scale. And then you have the decrypted file, and you're good to go. And you would do just the same thing to encrypt the file. So vaults. Vaults are kind of nice. The only thing I'm always afraid of, if you have the vault, and only that is having your secrets, and you just query the vault. What if the vault, especially with HashiCorp Vault, what if the vault server is not available? I mean, yeah, I know you're setting up a 3-node cluster for high availability, but still, if you shoot down that cluster, your application is still down in its entirety. So for me, this is always kind of a trade-off. Yes, it's very easy and nice to handle that, but it's also easy to shoot yourself in the foot if you don't handle it correctly. So this is HashiCorp Vault. I don't think we had someone better here today to talk about that. Then there is Ansible Vault. Ansible Vault is a bit like the shell script I've shown you in the previous example. It's just nicely integrated into Ansible. You provide an additional parameter that you need to decrypt the file, and it will just ask for the password when it runs. And if you set it up correctly, the decrypted version is always only held in memory, so there is no way to push the plaintext file. So you cannot really mess it up. And then you have Ansible Vault, and then you can use that to edit, view, rekey, or whatever do with the file. And that file, again, you can easily push to your source control management. And then there is the secrets pit. I think it has the code name Frisp, which is from some CMS system, but they have a very interesting approach. So they keep the systems on S3 on Amazon, and to get the secrets, they'll use AWS Lambda. So they have the Lambda functions to actually fetch the keys for them. And on Amazon, you cannot only create credentials for a specific key, but you can give credentials to your servers, for example. So your EC2 servers can just be allowed to access that S3 bucket. Nobody else can read it, and then they can use Vault to actually fetch the data off it. So this is kind of a pretty fancy approach. You don't have any failing components. All you need is S3 and AWS Lambda to fetch secrets for you and get that into your application. Okay, next up, trust. This is always like, who do we trust, who don't we trust? So my line was always, okay, I have my code on GitHub, so obviously I need to kind of trust GitHub. I have a build server, that build server needs to be able to read stuff. And obviously I need to trust my hosting company. So only these will get access to my code and my stuff. And GitHub and the build servers will only ever see my credentials in an encrypted fashion. Other services I don't really trust. So there are nice services with GitHub add-ons and small products. I mean, these people don't mean in any bad fashion. But again, this is probably like a two-person team doing it on the side. Nobody has time to think about security really deeply. So those are probably easy targets. Many people are using a service that's probably open source or free to use or cheap to use. If you break in there, you probably can get lots of tokens and credentials. Like previously, I wanted to use WhoBoard, which is kind of a Kanban board based on GitHub issues, where you can just drag around your tickets to assign them. But they need full access to your GitHub account. And I never kind of felt comfortable with just giving up all my secret keys to them because, yeah, I'm sure they are well intended. There are many competitors, all of them pretty small, mainly doing it on the side, like Waffle.io and whatever. They mean well, I'm sure, but I'm still like, nope, this is one step too far. Next up, check your code. If you have a big team and you don't really trust all your team members, or like you have that one colleague who is screwing up every now and then, you can use Git drop, which is a nice tool which will just check your commits and find bad stuff you have in there. So it will just check your code and tell you, okay, here you have committed an AWS key, and here you have committed, I don't know, whatever credentials. So it will check your code for that. Especially for bigger teams, this is kind of helpful. So yeah, if you're a small team, probably your colleagues will be offended. If you're a bigger team, you can probably push it through more easily. Okay, so that was pretty quick. We can already wrap up. So first off, there is no magic. Because I've had kind of the feedback on this talk in the past, like, so where's the magic? And unfortunately or fortunately, there is no magic. It's just about like doing your homework and not falling for the obviously bad stuff. And then you're probably better than 95% of the others. And yeah, nobody's trying to hack those 5%. Everybody is going for the easy targets. And just to give you some more examples, so somebody was a developer and said like, oh, I only needed S3, and suddenly they had 140 servers mining Bitcoins. And how could that happen? Because yeah, that person had pushed their AWS keys and realized within 5 minutes, did a rebase and force push and thought, well, it's gone. Obviously, multiple failures. First off, if you have pushed it, it's compromised, rotate your keys. Secondly, if you only need to access S3, why can your access tokens even start EC2 instances? This is just totally pointless. Next up, billing alerts. If you had billing alerts, you would probably realize 140 instances is much quicker than at the point when AWS calls you, because this is normally when your bill is getting pretty high only. And yeah, finally, obviously never commit your credentials. And then there was this guy who had, obviously it was a bug in Visual Studio, I don't know, where you could create right from Visual Studio, where you could create your GitHub account, and it looked like it would be a private account, but obviously it created an open source account, or an open account. And yeah, he had a bill, $6,500. Normally, if you need to pay that, or if Amazon says, okay, this time we'll just cover it for you, I don't really know why some people need to pay and others don't. It seems to be kind of a negotiation thing. So if you have those kinds of problems, try to negotiate you don't always need to pay. So this guy had this problem, and again, he complained mightily. I think it was on Hacker News, and yeah, he just said like Microsoft is crap and it should never have happened. And then kind of people responded, well, if you're a seasoned developer, why are you actually pushing your credentials to GitHub anyway? This is totally a bad practice, don't do it. This just causes for trouble. And yeah, it does, so don't do it. Otherwise, you will probably end up like this. So then Bob will need to take care of because you've screwed up mightily. Yeah, any questions? Yes?
Is there any cryptographic reason why Amazon doesn't provide recovery codes for the two-factor thing? Like something you print on a paper and put in the system?
I don't know why, but they don't. Because yeah, it's right. Google provides those backup codes, and I think GitHub as well. But Amazon doesn't have them. They just obviously it's a good thing for lawyers to have that. No, I don't really know. I mean, you don't need the codes I mean, you don't really need the root account, but we still want to get it back at some point. It's just like, I don't know. It was really hard, and also it costs a lot of money. Don't do it. Actually, did anybody have a security breach on a cloud hosting provider already? No? Obviously, it's just a mistrust of the cloud. Just, like I said, a very German thing. But the Austrians are the same, no worries. Any more questions? No questions? Okay, then. Thanks. We have still lots of Elastic swag downstairs. If you have any Elastic questions, I'm also available. And otherwise, yeah, thanks a lot.